Okay, then I will introduce what is a discrete valuation and discrete valuation ring, respectively. Okay, let's go ahead. Let K be a field. Then a discrete valuation is a function from field to plus infinite such that the function nu is given that satisfies like homomorphism property. And the second property is a little strange, but is very useful later. The sum of x plus y and go to function nu, that is always greater or equal than between minimum of two function. And that is plus infinite if only if x is 0. Okay. And if a Noetherian domain R is given, the ring R is called a discrete valuation ring, so-called DVR. Because this is integral domain, we can think about a function field of fraction, okay? Going to G union of infinity such that for any subset 0 union nu x is greater than equal to 0, the following rules satisfies that we call the domain R is called DVR. Okay? Based on example, we can check that. The ordinal function, rather than ordinal function, integer is a discrete valuation ring. Because first we can think about this function. I will define n plus infinite, but we can extend the range is to integer is no problem. That is clearly a discrete valuation. Check that, this property. This is clearly discrete valuation. Furthermore, since Z is a Noetherian or integral domain, the field of fraction is rational number. That is not a field, okay? We can make a field structure. When we see this definition of discrete valuation, K should be a field, must be field, okay? That is field, okay? And when we extended this part, and as I said, we can define based on the logarithm property. We can extend, there exists the following function which satisfies given condition. So integer g is clearly discrete valuation ring. Based on this reason, the process, the ordinal function extended g from g to q is the process of the when you view this process in a abstract algebra sense, that is finding a discrete valuation, which satisfies field K, okay? Apart from this example, we can find several examples of a discrete valuation ring. Field is clearly ring, okay? So, if K is a field, we can think about that is a clearly ring. Then, so we can think about a discrete valuation when K is a field. In fact, if we define if A is non-zero element, then this definition satisfies a discrete valuation. So K is itself a discrete valuation ring. In that case, we call K rather than K, that new trivial valuation. That would be not useful, but that is important. Including the next example, That is important example because when we think about, I'll give an exercise problem sheet in the next section that is related to tropicalization. Or tropicalization means that given a polynomial, user polynomial, as a tropical polynomial that is changed into tropical polynomial. But in this case, a trivial valuation is plays an important role when you think about a tropicalization in a tropical algebra. Another important example in the tropical geometry is a Puget series and or Palmer power series. I will extend notation, introduce a notation. If K is a field, I'll explain this notation means that it's denoted by, that is a infinite Palmer power series. Literally, that is written as like this. In this case, not G, T, I, and we define this notation just coordinate using a coordinate. Ti is an infinite basis, but using a coordinate we can use like this. There is infinite basis. Okay. The important fact is that when we can define the addition or multiplication between the Palmer power series. That is a ring. Precisely speaking, that is a Noetherian ring. Then, how we can, the next step is that because this domain, because this is Noetherian domain, we can extend that is ring structure to a field. Okay, that is denoted by like this, and that is a field structure we call the Palmer power series that satisfies a field is a Puget series, where that is written as like this. I will explain detail in my lecture note. If the Palmer power series is contained in KT, which means that where that is a rational coefficient which have a common denominator. Okay, and the function because this guys is discrete valuation ring claim. Okay, it's a DVR because there exists a field of fractional physics to g to infinite such that if we take a function it's defined like this. Anyway, that is really complicated, but we can extend the field of fraction, so-called Fourier series, or defined like this, and there exists discrete valuation. So that is a so this guys is discrete valuation ring. That is also important in tropical geometry. Because when you define a tropical polynomial, I started the tropical polynomial is a univariable in a lecture 2, section 2. And the section 3, I will explain this guys into a multivariable using an exponential vector. But that guys is a so-called a Laurent series. So we can extend the tropical polynomial into Laurent series. So when we see the textbook or lecture in the tropical geometry, the tropical polynomial is defined a Laurent series. Okay, that is based on this Puget because of the the former series is a discrete valuation, and the function is defined like this. This background why the general tropical polynomial is defined a Laurent polynomial.